right, this morning we have wise guy Matt Sellens here in our studios.
He's crawled into the studio with a couple of entomology students from the U of I, and Jamie Zonheiser is carrying... I'm standing on this side of the table because I don't...
Yeah, I'll be we've been assured he won't bite. No. Hopefully.
So if you make them mad, they make a funny noise, right?
They do. They, if you get them mad, they'll hiss, actually.
Yeah, this is a giant hissing cockroach, and we're going to use him to show what the parts of these bugs are. If you remember, what I asked last time was, why can't bugs or ants be 6 feet tall? And I got some great answers. And in fact, one of the answers I didn't even expect was from Rebecca in Indianola, and she says if ants were 6 feet tall, they would eat more and more, and there being so many of them, we'd run out of food. So that's a great answer.
That's a very good answer.
And the answer I was thinking about was because their exoskeletons, their outside skeletons, wouldn't be strong enough to support their weight. And so that's what I wanted to show. And so this guy has an exoskeleton. All the hard stuff is on the outside. So he's like a candy that's crunchy on the outside and squishy on the inside. And so on the inside...
dipped him in chocolate, Matt. That's for me.
Right. And so I can show that things can be made very strong even if you just have a thin shell on the outside. So to illustrate that, I have some cups here. And here's just a Dixie cup I got at the store. Okay. And if you squish them like this, they're very, very weak. But if you push on them just right, they're actually very strong. So I'm going to hop up on the table and show that I can...
Okay.
I can actually... This thing will support all of my weight. Ta-da!
Wow.
All right. Okay. And my weight is pretty big, and so these things, even though if you push on them sideways, they're not very strong. If you push on them just right, they are extremely strong. Now, the problem is, as things get bigger, they get very, very heavy. So let me show you here. These are 2 bags. One is about half the size of the other one, and if you just compare how much you weigh, I fill them with water with a little coffee in them. This one's about 8 times heavier than that one is.
Yeah.
Okay, but it's only twice as big. So as you start doubling the size of bugs, they get really, really, really heavy very fast.
Okay.
And the problem is that their legs can't stand that strain. And so what happens is, even though if you imagine their legs are cylinders, their legs have to bend, and the bendy part there, their joints, is where things will break.
Okay.
So it won't work. So little tiny bugs, the strength of an animal is proportional to its area. The weight is proportional to its volume. As it's very small, it has a fairly big area for its volume. So little tiny bugs can often lift things many times their own weight, and they can jump very high.
Is that why they say ants can carry 80 times their weight?
That's right, because they don't weigh very much, but relatively speaking, they have much more surface area per volume ratio, is the way we say it, than something that's big. And so these things are very strong.
Jamie, can you make a...
We'll give it a shot. Sometimes they get a little bit too acclimatized.
There he goes. Did he hiss?
You can hear that?
Yep.
Yes.
Yeah, that's cool.
Woo.
All right.
Sounds like tire pressure.
Right. So we got a whole bunch of bugs to show you in the second segment.
I'll be in the studio for that. I think I'll let Matt do that one. Okay, well, thank you very much. We'll hear more from the bug later. And still ahead, we're taking a trip back into time in today's Wish You Were Here segment. Plus, what you got cooking?